First thing to notice here is that we have a fraction, but specifically we have one term in the denominator. And anytime you have one term in the denominator, you get super excited about that because that does not mean that you have to go through the quotient rule. One term in the denominator, and we'll talk about the quotient rule later, but this one term in the denominator is incredibly important for us because it means that we can actually solve it by just splitting up each of these based on that common denominator. So our first step here is going to be to simplify. And the simplification is going to be about splitting up because we have that common denominator of just one term. So this will have f of x is equal to 4x cubed over x squared minus 2x over x squared plus 1 over x squared. Now, keep in mind with all the simplification that what you want, especially when you're just thinking about basic derivative rules, is x to a number in the numerator. So we need a bunch of terms and we need them kind of to look something like x to a number in the numerator to apply the power rule. All right, so to do this, we have first the x cubed over x squared. We simplify, subtract the exponents. 3 minus 2 gives us x to the first. Here, when we subtract the exponents, we're going to get 2x. Now, when I take 1 minus 2, I get a negative 1 exponent. I could move that down into the denominator to make it positive, but remember, we want x to a number in the numerator, so I will keep it written just as follows. Now, the 1 over x squared is simplified, but remember, we want x to a number in the numerator, so I'm going to choose to bring this x squared up to the numerator. And when I do that, I will get x to the negative 2 power. Now, it's very tempting to think that's it, we're done, that's our f prime, but that's not our f prime. That is just our simplifying. So once we have our simplifying done, then our second step is we take the derivative, and that's where we do the whole bring down, subtract 1, the standalone constant goes to 0. We use our derivative rules. So in this case, the first term that we see is 4x to the first. And we talked about when you have that first power, it's very special. It's a linear term. And when you have a linear term, your derivative will simply be the coefficient on that linear term. So if you bring down the exponent, subtract 1, you get x to the 0, and that x to the 0 becomes 1. So this will just be 4 here. So again, it's 4 because it's a linear term, so we use the coefficient. All right, now the second term, we bring down the negative 1, so we will be multiplying negative 2 times negative 1. So that gives us a positive 2, and then subtract 1, negative 1 minus 1 gives us negative 2. And then the last term, we bring down the negative, so we have negative 2x to the negative 3, because we have negative 2 minus 1, and that gives us negative 3. Now, be really careful here if you do decide to bring down these exponents. This is just a base to the exponent for that second term, and this is just the base for the exponent for the last term. So if I were to bring down the negative exponents, make them positive, the 4 would remain unaffected by this. So it'd be 4 plus, and then for the second term, I would have 2 over x squared. And for the last term, I would have negative 2 over x cubed. So that would be my simplification if I wanted to get rid of the negative exponents.